Majesties, Your Royal Highnesses, distinguished representatives of the Nobel Peace Prize laureate, Your Excellencies, distinguished guests, ladies and gentlemen, welcome to the Nobel Prize Award Ceremony. I am Einstein, your host for today. The prize goes to Dr. Kim for excellent achievement in Physics 1A03. Physics is impossible! For years, I've tried to pass the impossible labs. The TAs never give me the coveted check marks of glory. Now, I take my revenge.
A thief!
So the question is, how long will it take for Dr. Kim to catch up to the thief, and what is the distance traveled between them? Let's just assume that the thief ran 3 meters per second, and Dr. Kim accelerates for 5 seconds to reach 5 meters per second. We can find the acceleration of Dr. Kim using the formula v2 equals v1 plus acceleration times time. We know that the second velocity would be 5 meters per second. And he would start off from rest, so it would be 0 plus acceleration times 5 seconds. Acceleration would be equal to 1 meters per second squared. So we can solve for delta x using the formula v times time plus 1/2 acceleration times time squared. However, we still know delta x and time, so we need to know the formula for the thief. The formula for the thief would be delta x equals velocity times time. So to reiterate, this one is Dr. Kim. And to make things simpler, we will use velocity subscript k. And this one is a thief. And so we will use subscript t. So we can solve for the time, since the delta x between both of them will be equal. The equation will look like vk times time plus 1/2 acceleration times time squared equals vt times t. So we know every single variable except for t, so we can solve for time once we plug in all the variables. So vk is 5 meters per second times time plus 1/2 times 1 meters per second squared times time squared equals 3 meters per second times time. Using the quadratic formula, we will find that t will equal about 6 seconds. So 6 seconds would take Dr. Kim 6 seconds to catch up to the thief. Then, to find the change in distance between how far they would travel, we would just plug 6 seconds back into this equation. So delta x equals 3 meters per second times 6 seconds. So the delta x would equal 18 meters, but if we were to keep sig figs, this would just equal 2 times 10 to the power of 1 meters.
So I was running at a constant velocity, so as you can see my slope is equal to a constant number. It doesn't increase or decrease over time, and that is because the slope of a displacement versus time graph is equal to velocity, and as I said, my velocity was constant.
Alright, so we both started at the initial position. I was at rest, and I sped up and was able to catch up to the robber at 6 seconds. So the displacement here was 18 meters, and the slope of this will give us the velocity. So since I accelerated until 5 meters per second at 5 seconds, it will be a constant acceleration here. And then my velocity will just stay constant after I reach 5 meters per second.
Yeah, so remember that acceleration is a product of the slope of velocity versus time graph, which is why his slope was constant. As for me, since my velocity was constant, as can be seen here, as we just talked about over there, my acceleration would have to be 0. And then the slope was 0 here, and therefore my acceleration is 0.
Yes, here also the acceleration is constant at 1, and then once my velocity didn't change,
It becomes 0, yeah.
The power of physics.